This is the video for Chapter 1, Section 1.1, Sampling. Statistics is the study of the procedures for collecting, describing, and drawing conclusions from data. In statistics, we often study populations as well as samples. A population is the entire collection of individuals being studied, right? This is really what we're interested in. And a sample is a subset of that population that contains the individuals being being studied. So then why do we even consider samples if we're really concerned with populations? Well, the answer is that we're not always able to collect data from every single individual in the population. All right. Collecting data from all individuals of a large population can be at best impractical and at worst impossible. Right? Imagine if you wanted to collect some data on every resident in the United States, right? It's really not possible to collect data from all 330 million people who live here. So you probably want to sample and get that data and then make an inference about the U.S. population from that sample. So that's what we do, right? We sample our population and then analyze the data from that sample and then make an inference based on the population. And that's really what we're going to be focusing on today is how do we sample from a population? There are many different ways. I'm typically going to lead with an example, talk about the kind of sample that's been done, and then make a general definition of the sample. That's how we're going to do this. So pause your video, read example 1. So most basically, a simple random sample, known as an SRS for short, is just a fixed number of individuals that are randomly sampled from a population. That's it. Sometimes we say a simple random sample of size n. All right. How would we construct a 50-person random sample, right? A simple random sample of, not of 50 people, of 50 apples, Simple random sample of size 50 apples. Well, you could just say, just randomly sample 50 out of 1,000 apples. Yeah, but how would you do that? Let's be a little careful. First, number the apples 1 to 1,000. Use a random number generator. Random number generator to select 50 random different numbers, right? Repeated numbers can be discarded, right? And then choose those numbered apples. Right? That's what you do. It's actually a couple of steps, and it would take a long time to number those apples 1 to 1,000, right? Unless they were all lined up. So a simple random sample might be a straightforward concept, but it's not always the easiest to actually perform. And just something to keep in mind. Simple random samples are great if you can do them in a reasonable amount of time. But let's see if there's anything easier we could do. Pause your video and take a look at example 2. What do these two samples have in common? Well, they're both convenient, right? They're both easy to do. Well, both convenient and potentially biased, right? Do you know what biased means, right? It means it might be favoring one result. So that's not a good thing in statistics. We'll focus more on bias later on in another video, but for now, biased, bad. A convenience sample is a sample that's not drawn by a specific methodology, right? In particular, convenience samples are done because they're just the most convenient things to do. So why did these people use convenience samples when there's a risk of bias? Well, it's just sort of a natural thing to do, right? If you want to know how people feel about something, or if you want to know how something is, just sample the first individuals that are available to you. It's a totally natural thing to do. We've probably all done it. But that's not super scientific. It could be problematic, right? Especially in these two cases. What are the pros and cons for convenience samples? Well, I mentioned one con is bias. I mentioned a pro is just ease. See if you can think of any others. Okay. Let's look at another example, right? Pause video, read example 3. So what's wrong with a simple random sample? A simple random sample could, I guess you could say, not underrepresent, but possibly undervalue women's thoughts regarding the company, right? Because women are so outnumbered by men, they might get lost in the shuffle. So what you would say is, if the company really wants to hear from men and women equally, then they shouldn't use a simple random sample. They should use something else where they sample as many men and women as each other, and that way they get equal. They get an equal say. So we'll just say if a company wants to value women's, I'll say, evaluations equally to men's, then it should sample an equal number oh my goodness gracious of men and women. Right. Or maybe you could say it might want to consider doing this, right? Sometimes this is not possible, and there are ways to weight things appropriately, but sometimes you just want to sample men and women equally. So anyway, when you want to do this, this is called a stratified sample. Whoop. stratified sample, right? A stratified sample is a sample in which you divide your population into groups, and then randomly sample within each of those groups. And these groups, by the way, are called strata. I think it's a Greek word, right? And that explains where we get the term stratified sample. So think about the pros and cons of that sampling, stratified sampling. Now, read example 4, pause the video. Now, is this stratified sampling? Because it looks like it. It looks like we're dividing the population to 48 hospitals, but then we're not randomly sampling from each of the 48 hospitals. We're sampling completely all the individuals from each of 5 chosen hospitals. Okay? So no, this is not stratified sampling. I'll just say, let's use complete sentences here. No. Not all hospitals are sampled from. Only 5 are, and all individuals from those 5 are sampled. Right? So this is not a stratified sample. It's called a cluster sample. Individuals are grouped into clusters. We call them clusters because we're doing cluster sampling, right? And then all individuals in each cluster are sampled. So think about the pros and cons to that. Now, let's look at another example, right? Another kind of random sampling, right? Choosing every, let's say, 5th one, right? Is this a simple random sample? No. And it might look like it is, but it's really not, because after the first bottle that's chosen, all the other bottles are now predetermined. If we choose the 5th one first, we know then that we're going to be choosing the 10th, 15th, 20th, 25th, etc. So those all are not randomly chosen, the way, at least not in the way that a simple random sample was, right? In a sense, you could say they're randomly chosen because the first one was randomly chosen. They're dependent on the first. But in another sense, the choices are dependent on each other, and that's not true for a simple random sample. Each bottle after the first choice was determined by the first choice. Okay. And this is called a systematic sample. Right? There's some sort of a pattern going on, right? Compared to a simple random sample, which has no pattern. Okay, now let's use us as an example. Suppose I want to know what the kids are listening to these days. I say, hey, what music are you listening to? I'll jot down answers from the first 5 students who respond. That's called a voluntary, response sample. Voluntary response sample, right? The sampled individuals are the ones who volunteer to be sampled, right? And as always, there are pros and cons with this. And one other thing, I wish I devoted more time to this, but this is all the time we have. We've been talking a lot about samples to infer about a population, right? When we take the sample and we analyze the data and maybe we come up with a number or some sort of a value or name for that characteristic, or we just analyze all the different characteristics, we call that a statistic. Characteristic of a population is called a parameter. Okay? That's all for this video.